Good day everyone, the students of class 8. We are starting over here with the chapter 1 of the maths, that is the rational numbers. So today we will start with the chapter 1, rational numbers. Before starting with the rational numbers and before telling you the definition of the rational numbers, I would like to have a revision and have an overlook on some important things. That is, the first is natural numbers. You must have studied in your junior sections. Natural numbers, as you all know, that starts from 1, 2, 3, 4 and so move on. The natural numbers are notated by the capital letter N. The next is whole numbers. Whole numbers, as you all know, that the whole number starts from 0, 0, 1, 2, 3, 4 and so on. 0, 1, 2, 3, 4 and so on. The notation of the whole numbers is given by W, capital W. The next is integers. The integers has a specification that they contain both the natural and the whole numbers, and the natural numbers are with the negative sign. That is, the integers are those which you can write it on the number line also. That is, the integer starts from -3, -2, -1, 0, 1, 2, 3 and so on. So it has 0, -1, -2, -3, 1, 2, 3, that it has positive natural numbers with the negative natural numbers and 0. So these 0, 1, 2, 3 are called positive integers. Positive integers. And these negative numbers are called negative integers. And this 0 is called zero integer. 0 integer. The fact about the 0 is that it is a even whole number. 0 is also called the even whole number. And if you want to represent these integers on a real line, just make out a real line. Mark out over a here 0, 1, 2, 3 and so on. And here like this, -1, -2, -3 and here so on. This is the way you are going to represent on the real line. Integers are notated by the capital letter Z. Integers are notated by the capital letter Z. Rational numbers are those numbers which can be written in a form of P upon Q. Rational numbers are those numbers which can be written in a form of P upon Q, such that Q should not equal to 0. आपका Q की वैल्यू कभी भी यहाँ पे 0 नहीं होनी चाहिए. तो ये आपके क्या कहेंगे, P upon Q is a rational numbers. There are some important points you have to remember. That is, all the integers, okay, even including the 0 also, okay, all the integers are the rational numbers. You can call all the integers to be a rational numbers, but vice versa not true. All the rational numbers cannot be integer. It is not possible for you. So integers can be called as a rational numbers, but all the rational numbers cannot be called as integers. For example, we have taken a word number 2. 2 can be written as 2 upon 1. This is your P and this is your Q, which is not equal to 0. It means it is a rational number. Rational number. Similarly, I have minus 3 upon minus 3. So I can write minus 3 upon 1. Again it is in a form of P upon Q, and again it is a rational number. So all these type of numbers which are the integers can be called as a rational number, but it's not possible for you that if you are given with the minus 3 upon 1 you can make it like this. You cannot take it as a minus 3 and you cannot call it as a integer. It's not possible for all the numbers. For I will give you another example like this. Just you have 2 upon 5. It is a rational number. It is a rational number, but it cannot be a integer. You just see that it is a rational number, but it cannot be a integer. That's why we do not take it as to be a back to the integers. For your information, that is rational numbers are notated by capital Q. So always remember the abbreviate used for the rational number is capital Q. Now the next is positive rational number. Positive rational numbers are those numbers in which P upon Q form both have a positive sign or both have a negative sign. That is, I have told you that rational number can be written as a form of P upon Q such that Q is not equal to 0. You have the two susceptibility of the positive rational numbers, that is both the P and Q have the positive sign, or both the P and Q have the negative sign. Okay, in this type of form you have a positive rational numbers. For example, 3 upon 2, it's a positive rational number. Minus 5 upon minus 6 is a positive rational number. How? Because the minus sign rationalize with each other. So this is the way you have a positive rational numbers. Another one is the negative rational number. Another one is negative rational number. Negative rational number. In this, whether you have a sign in negative sign in the numerator or you have the negative sign in the denominator. In any of the one case, you can have the negative sign either in a numerator, either in a denominator. So in this type of question, suppose we have taken earlier the example is 3 upon 2. Suppose we have minus 3 upon 2 or 5 upon minus 6. This type of question to be have in a negative rational numbers. Properties of rational numbers. Properties of rational numbers have both the addition and the subtraction properties. So we are going to discuss about the addition properties over here on the left hand side. Additional properties. And on the right hand side we will discuss the subtraction properties. Subtraction properties. So how you are going to use the subtraction properties and the additional property? The property is the closure property. Closure property and a closure property for subtraction. It will be easy for you to understand. Closure property under addition, closure property under subtraction. Whenever you take two rational numbers and add them, again you will get a rational number. And if you take two rational numbers and subtract them, again you will get a rational number only. We will discuss with the two by taking the example. So suppose I have taken 2 upon 5 minus 1 upon plus 1 upon 10. Okay, you have 5 in a denominator and 10 in a denominator. The first you have to do that you have to take the LCM. Okay, if you take the LCM of 5 and 10, we will have a 10 as LCM. Okay, I know you have already knows how to take the LCM. I'm not going to tell that. 5 and 10. So you will have the LCM to be 10 over here. Okay, now take a 10. 5 2s are 10. 10 into 1, that is 4 plus 1. You will get 5 upon 10, that is 1 upon 2. It is in the form of P upon Q. It's a rational number. Same example we are going to carry out over here on the subtraction also. Two upon 5 minus 1 upon 10. Again, the LCM of 5 and 10 is LCM of 5 and 10 is 10. Again, 10, 2 into 2, 1 into 1, that is 2 2s of 4 minus 1, 3 upon 10. You can see in both the cases that 1 upon 2 and 3 upon 10 both are the rational numbers. So in the closure properties of both, that is addition and subtraction, you can see 1 upon 2 is also a rational number and 3 upon 10 is also a rational number. So both are the rational numbers. And now under the heading of properties of rational numbers, we will discuss the next property after the closure property, that is the commutative property. Commutative. In this property, it is very necessary that in both the equality should be equal. That is, A plus B is equal to B plus A. So under the addition property, A plus B should equal to the B plus A. If you add both of them, you will get the equality over here. While in the subtraction, A minus B is never equal to B minus A. It will always differ by the minus sign. Now we will discuss the example is we have taken the two rational numbers, that is 2 upon 3 plus 4 upon 9. To verify the commutative property, we are taking the numbers 2 upon 3 and 4 upon 9 is equal to 4 upon 9 plus 2 upon 3. For this verification, we have to do what we have to do, 3 and 9. We have to take 3 and 9 LCM. Just take the LCM of 3 and 9. 3 and 9 LCM, how you are going to take? 3 1s are 3, 3 3s are 9, 3 1s are 3. 1, 1. Now LCM will be 9. After taking the LCM of 3 and 9, we get the LCM of 9. Now we will, on the left hand side, first see the left hand side, the LHS one, 3 and 9 LCM. So put a 9 over here. 3 1s are 3, 3 3s are 9. 3 3s are 9, that 3 multiple will come over here. 9, 9 1s are 9, 9 into 1, 9, that is the 1 is a multiple. You will multiply this 1 in the numerator. So 3 2s are 6, 4 1s are 4, equal to. Similarly here you will take the LCM, that is 3 and 9, again you will get 9 as an LCM. Again 9 LCM. 9 ones are 9, 1 is a multiple, 3 threes are 9, that is 3 is a multiple. 4 into 1, 4, 3 twos are 6. 6 plus 4, 10 upon 9. 4 plus 6, 10 upon 9. You can see you have verified. Yes, we have verified that we have taken two rational numbers and on both the side they both are equal. Hence it follows the commutative property. The same thing we are going to discuss for the commutative property in the subtraction, that is 2 upon 3 minus 4 upon 9 is not equal to 4 upon 9 minus 2 upon 3. Okay, so again we will take the LCM as we did it in the before. Okay, so again LCM of 3 and 9, that comes to be 9. Again 9 over here LCM, 3 ones are 3, 3 twos are 6, 3 threes are 9. So 3 will be a multiple, 9 ones are 9, 1 will be the multiple. So 6, 3 twos are 6, 4 into 1 minus 4. Again we take a LCM. So 3s are 9 and 3, that is 9. 9 into 1, 4 into 1, 3 threes are 9, 3 is a multiple. 4 ones are 4, 4 minus 6. 6 minus 4, that is 2 upon 9. 4 minus 6, that is minus 2 upon. Are they equal? No, hence is verified. It means that is the commutative property follows by the addition, while the commutative same properties does not follow by the subtraction. Under addition, the associative property. Under subtraction, associative property. Associative property in the addition holds, while in the subtraction associative property doesn't holds. As we have did in the commutative property, we are going to take the example and prove it to you. In the associative property, you have to take the 3 element set A plus B plus C should equal to A plus B plus C. You have to show this thing. While in the subtraction also, A minus B minus C is not equal to A minus B minus C. This is the associative property. We will discuss it over here by taking the example. Just take example. Take 1 upon 2 plus 3 upon 8 plus 1 upon 16 is equal to 1 upon 2 plus 3 upon 8 plus 1 upon 16. We have taken this example just to verify the associative property. For what we have to do, we have to take the first LCM. The LCM of 2 and 8 is 8. 8. Now 2 having a 8, that is 4 times. 2 4s are 8. The 4 times 2 is a multiple of 8. And 8 times 8 into 1. So again we have a 8 over here. 4 into 1, 4 plus 3 into 1, 3 plus 1 upon 16 is equals to. Now what we have to do, we have to take this LCM of 8 and 16 over here. So 1 upon 2, LCM of 8 and 16 will comes to be 16. 16, 8 ones are 8, 8 twos are 16. 16 into 1. That is 3 twos are 6, 6 plus 1 like this. 4 plus 3, 7 upon 8 plus 1 upon 16. Here 1 upon 2 plus 7 upon 16. Okay. Now again we take LCM of 8 and 16, which comes to be 16. 8 ones are 8, 8 twos are 16. So 8 into 2, 16 into 1. 7 twos are 14 plus 1 is equals to, again we take LCM 2 and 16, that is 16. And again we have 16, 2 8s are 16, so 8 will be the multiple, and 16 into 1, that is 16 into 1, 16, that is 1 is the multiple. So 8 into 1, that is 8 ones are 8, 7 into 1, that is 7, 14 plus 1, 15 upon 16 is equal to 8 plus 7, 15 upon 16. Now you can see that the associative property under the addition holds. This is the way you should take for the associative property. Now the same example we will take to show that the subtraction property does not hold in the associative one. Now again we take the same example, 1 upon 2 minus 3 upon 8 minus 1 upon 16 is not equal to 1 upon 2 minus 3 upon 8 minus 1 upon 16. This is for the subtraction. Again we will solve the bracket, as we have already known, with the bracket should be solved first under the Bodman's rule. So we will take the LCM of 2 and 8, and again it will come 8. Now the LCM 2 4s are 8. So 4 is a multiple, 8 ones are 8, 1 is a multiple. 4 ones are 4, 3 into 1 minus 3. In a bracket put minus 1 upon 16 is not equal to, again we will solve the bracket first, 1 upon 2, 8 and 16, the LCM will be 16. 8 twos are 16. So 2 will be the multiple, 16 into 1, that is 1 is a multiple. 3 twos are 6, 1 into 1, that is minus 1. 4 minus 3, 1 upon 8 minus 1 upon 16. Not equal to 1 upon 2, 6 minus 1 minus 5 upon 16. Again we take LCM, 1 upon 8 or 16, that is 16. Again the multiple will come. 8 ones are 8, 8 twos are 16, 16 into 1. So 2 ones are 2, 2 minus 1. Again we will take the LCM, that is the LCM will come 16, 2 8s are 16, 8 is a multiple. 16 into 1, that is 1 is a multiple. So it will come 8 ones are 8, and 5 into 1, that is minus 5. 2 minus 1, that is 1 upon 16, and 8 minus 5, that is 3 upon 16. Are they equal? No, they are not equal. So it verified that a subtraction does not hold with the associative property. Now the next property is identity element. In the addition, it is also called additive identity. And in subtraction, it is an identity element. Identity means which maintains your identity, the proof of your existence. So whenever you are going to add 0 to any of the rational number, you will get again the rational number, and it does not change any value, any changes in your rational number. It means 0 is an additive identity or an identity element in both addition and subtraction. For example, we will discuss over here. That is, just you have P upon Q as a rational number, and if you add 0 over here, again you will get P upon Q, a rational number. It does not changes, it does not come with any change in the rational number. Again in the subtraction, we have P upon Q minus 0, and again you will get P upon Q. So it's an identity element. An important thing to remember is, that is, if you add 0 like this, 0 plus P upon Q, again you will get P upon Q. So if you add identity whether on the right hand side or whether on the left hand side. In the addition especially, you will get again P upon Q as a rational number. But in the subtraction, please remember that you have to make the 0 on the right hand side. Do not ever make 0 on the left hand side, because if you try to minus this, it will change your rational number. So do not take the identity element in the subtraction on the left hand side. You do not have to take this. You only have to take P upon Q minus 0, that is give you P upon Q. Let's discuss with an example over here, that is 2 upon 7. I have to add 0 over here, which is identity element over here, and again you will get 2 upon 7. Okay, and if I add 0 plus 2 upon 7, nothing to be changes, 2 upon 7. So here 0 can be identity element on either of the side, whether right side, whether on the left hand side. And again we take an example over here, suppose 3 upon 5 minus 0, you will get 3 upon 5. So it's an identity element for under subtraction. But if you take like this 0 minus 3 upon 5, it will changes to be minus 3 upon 5. That is, you will get, your question is with the positive rational number and you get the negative rational number. It means that here 0 cannot be identity element. So this thing had to be remembered, that you have to take in the subtraction identity element always on the right hand side. Do not take on the left hand side. If you take it on the left hand side, your question will get changed. So 0 cannot be identity element if you take it on the left hand side. This is the identity element properties for the rational numbers. Now the last property that we come with, that the additive inverse. It is called to be additive inverse because if any element to any of the rational number get added with its inverse, you will again get the identity. But in the subtraction it is not possible. That if you want the subtractive inverse is not possible. The reason behind this, if you put a minus sign in any of the number, you will always differ with the minus sign. So because of the minus sign, we do not hold out with the subtraction property. So we discuss it over here. That is the additive inverse. Additive inverse. Additive inverse being such an element, that is, suppose you have a rational number a upon b. If you add minus a upon b over here, you will get 0, which in the case, as I had told you before, that 0 is an identity element. So to have an inverse, it is very necessary whatever the element you take, on adding with its original one, you will get a identity element. Let's discuss with an example. 2 upon 5. Okay, you want the additive inverse of it. So what you are going to do from your own, what you take, minus 2 upon 5. And if you add them, you will get 0. Again, just take 7 upon minus, you are given with the minus 7 upon 6. Just to have a 0 as identity element, what you do, you will add over here plus 7 upon 6. You get 0. This is the way you are going to have additive inverse. And these which are in the brackets, these one, minus 2 upon 5 plus 7 upon 6, these are the additive inverse. These are called the additive inverse because you have taken off your own, added in the given question, and you will get the 0 as an identity element. Okay. While in the subtraction, the problem with the while in the subtraction, why the subtraction does not hold with the additive inverse, or you can have an inverse element. The reason behind this should be get minus. So how you are going to do this? Suppose, I am just supposing because it is additive inverse is not possible over here. So we are discussing with the example. Okay, I have taken 1 upon 3. Okay, 1 upon 3 minus 1 upon 3. Okay. So 1 upon 3 is an element. You have taken a sign minus 1 upon and 1 upon 3. 1 upon 3 itself is an element, and its inverse is also 1 upon 3, which is not possible for you. That's why the additive inverse is not possible in the subtraction. Additive inverse we only take in the addition. There's nothing like additive inverse in the subtraction, because whatever your choice of number, you will get the another same number, which is not possible practically in the algebra. So these are the properties of the rational numbers which you are going to hold out with the exercises, and this finishes your exercise 1.1 and 1.2, both the notes one. Now we will discuss about the questions given in the exercise 1.1 and 1.2.